Hello everyone, and welcome to this LinkedIn live session broadcast to you from the ITAP 2024. I'm Britta Mittlefehldt. I'm the German manufacturing leader for Deloitte Consulting, and I have two really knowledgeable people with me today, Jimmy and Bernd, and we will talk about the value of software-defined manufacturing. Jimmy, maybe you first want to introduce yourself?
Happy to. Thank you, Britta. My name is Jimmy Asher. I'm the CTO for our smart manufacturing facility inside of the US, and a managing director inside of Deloitte with over 30 years of domain experience.
Bernd?
Hello, Britta, and hello, everybody. My name is Bernd Liebert. I am located here in Singapore with Siemens, responsible for the pre-sale support activities for Asia Pacific, everything related to factory automation and automation from Siemens.
So let's quickly set the scene here. So software-defined factories, software-defined manufacturing, where does this come from? So there has been a trend about software eating the world, software changing the world. We see this very much, for example, in software-defined vehicles, where software actually becomes the deciding factor, the value-adding factor, like for transportation. And we see this the same in manufacturing happening, where basically the value, the productivity is not decided anymore by which machines do I actually have, but how actually do I control and use these machines. So let's get started. Jimmy, so how do you see software-defined manufacturing within your clients?
So Britta, as you described, software-defined manufacturing is really how to move with increasing agility inside of the manufacturing environment. It has many different concepts that touch on infrastructure, touch on the actual physical requirements of product being manufactured. Ultimately, as you said, being able to take those design elements and move them into the factory to realize those into physical, tangible products. What we see inside of the landscape today is it's in various different pockets of that process. So there are items inside of how you take the engineering design and release that to manufacturing that's defined. Those might be in the concept of digital thread or PLM and release. But then there are other infrastructure and items and thinking about modern cloud solutions and how they realize manufacturing environments. So when we look across the manufacturing domain, it's really kind of interesting in that it's siloed, right? Some manufacturers start on the engineering side, others start on the manufacturing side. So as you think about software-defined manufacturing, unfortunately today it's a little bit out from a future forward perspective, but many of the concepts are here today and being realized by many. So very much in the evolution state.
Yeah, and so evolution basically means too that companies need to start today in order to actually at some point get to there. And coming from consulting, I know that transformation actually costs money, like software transformation especially. So Bernd, where do you see the business case for software-defined manufacturing?
Yeah, excellent question. So the business case clearly is to identify and detect early enough certain scenarios. And actually, this is one of our digital use cases that we are defined, because as you all know, digitalization is a journey. It's not a part number that you can just order. And to make it a little bit more feasible, we define certain use cases. And one of them, when we are talking about manufacturing, is the topic of simulation, of getting things in a simulated environment before you really deploy it to the machine. And that could be in the terms of simulation virtual commissioning, or the so famous digital twin, that you have the digital representation of a machine. And as Jimmy said, it is with a lot of investment, but the thing is that we can scale these solutions up. Nobody is putting you in with the complete software thing, because that will scare also people away. So we can start with a simple simulation of a function block and then slowly scale it up, simulating a behavior model of a drive, and then maybe top up the physical simulation that you really have the complete picture of the digital twin. And then processes can work in parallel. So normally you go in your virtual environment, you define your CAD drawings, and then you start with the engineering. With a digital twin and virtual commissioning, you can do things in parallel. You have your CAD data, you can combine it directly with the automation, you develop your libraries, and at the end of the day, your go-to-market is the value add You are faster time to market, you are reducing operation faults, maybe mechanical faults, and maybe machine downtime, because there are situations that you can simulate what you not think about before.
So basically, the savings are different, or the business case is different for each use case, but what you just said is, what they have in common is that they come to life when you scale, right? Is this something where you would agree?
It is. If we think about the different dimensions within inside of software-defined manufacturing, it really is at the increased case of agility. And some manufacturers think about that in the time to release the product itself. And others, it might be the quality or the manufacturing domain, being able to look at the work that fundamentally had dedicated product lines and being able to shift those so that you can run multiple different designs on them to help release product to the manufacturing environment as that need scales up or down or you're increasing new products.
So, I mean, how is this like placed by Siemens itself? I mean, so Siemens coming from a very hardware-focused business and now with software becoming more important. So is this something that you can see too in your organization and your products being mirrored, what the market there is shifting towards?
Oh yeah, for sure. I mean, nevertheless, you need a strong automation core. If you have a strong automation foundation, let it be a robust network and good automation portfolio, having a good standardization when it comes to interfacing, then you already built a foundation where you could build up all these different digitalization use cases. Let it be virtual commissioning, or what we are seeing now a lot is the decentralization. So we are talking about edge computing, where you really have a device on-prem that is basically gathering data and making data understandable for the next data layer, let it be a cloud system or a SCADA system or whatsoever. And we see a lot of potentials, also customers seeing a lot of potentials. We see from machine builders, they are switching maybe a little bit the business models. So you have customers that are having quite expensive machines, they rent it out, and with Industrial Edge, they get the KPI data and they charge by pay-per-use. So it can be a hardware in a hardware as a service scenario. So and there are shifts, and these shifts require data, and data is basically the core to build up all these different software use cases.
I mean, so when I, of course, develop a new machine or sell a new machine, then I'm in a type of a greenfield environment where I potentially can do this. But most of my clients, at least, they still have a legacy world that they need to deal with. And so when I look into a brownfield environment, so what would you kind of like recommend the client to just cancel everything and just kind of like start from the beginning? Like, or what would you say typically can stay and what needs to go in a brownfield environment?
So it's a good question, Britta, because if we think about the investment within inside of a brownfield environment, that might represent millions, if not billions of dollars to that particular client. So no, it can't be a simple rip out everything and deploy new. It could start in one of two solutions with a new product. Potentially, if I've got a new capability that I need to expand either the capacity of the plant, introducing some of those different concepts within inside of the new machines that are capable inside a manufacturing environment. The other paradigm would be looking at the infrastructure and thinking about where do you have either brittle point-to-point connections or areas that have a large amount of tech debt, and starting to extract those out and moving towards items that increase in robustness to a brownfield manufacturer.
But that means too, if I understand, like, so all of this, right, that we have to develop two new capabilities in terms of that maybe the team has to develop new capabilities to operate like this environment. So what do you think are the capabilities that a manufacturer needs to develop in order, for example, use your new solutions in their shop floor or use other solutions?
Yeah, I think it goes back away to the topic. I mean, brownfield, I think the key component when you're looking into brownfield sites, and here in Asia you have a lot of them, is the topic of connectivity. I mean, you want to display data, you make data usable, you need to get it somehow. And the connectivity is quite a big topic that also leads to the know-how of how do I gather the data. The topic sustainability is a quite big one everywhere. So how can I get energy data visible? Where do I measure? How do I get the data visible? How do I do a display and dashboard this? And all this mainly in the knowledge of the line builder, because they know best what they produce. And then based on that, we can create the transparency on top. But yeah, brownfield is like every digitalization case. It's a journey. Different sites have different needs. I mean, yesterday we learned there are people still counting manually with a piece of paper. Then others have maybe already sensors that are doing some counting. And then based on that, you define your use case, you define your digital strategy, and then slowly building it up and scale it up.
So, but actually from my experience, very often when I'm in a manufacturing environment, then for example, an operator cannot even tell me exactly what he needs just because he has never kind of like had the skill set to be a product owner, to kind of like tell me, you know, I as a product owner, I actually want to have this in my predictive maintenance app. And so what do you think, how do we upskill the teams in order to be able to do this? It's
an interesting question. We're working with a client right now that if you look at the chart, and actually there was a talk by another representative here, and they broke down their manufacturing environment into well over 30 different capabilities. The client that I'm working with, it's similar. It's a unified program thinking about not only aspects of, we'll call it OT awareness, so not that they need to be able to chart and program a PLC, but they need to be aware of how that instrument is used. Items inside of IT from a networking perspective, items inside of the engineering landscape of what are they actually doing from a business process within inside of that product. So as you think about the domain expertise across IT, OT, and engineering technology, those are incredibly important. But to your point, Britta, there's also skills around some of the softer skills that we see in software development, thinking about AI, thinking about product development, thinking about what that solution that I need to have and how I convince other stakeholders on the relevant needs. So the storytelling is an important part of that domain as well too. So we're seeing a lot of manufacturers thinking about that holistically from the standpoint of it's no longer just, I've got an OT engineer that focuses on the controls. They need to be conversational inside of multiple different domains so that they can route that information through the enterprise.
So once I'm then on the shop floor, have you seen that like a special process or a special function benefits most from digitalization? Like, for example, like a ramp up or quality maintenance. Is there anything where you say, okay, in this area, actually, mostly clients have a fast, positive business outcome?
I mean, when it comes to the machine and machine downtime and also maintenance, I think that over the years it developed a lot. I mean, we are starting with a standard industrial communication standard. One of them is Profinet, where really the diagnostic data is specified in your telegram, telling you, independent of what devices you have connected on your network, they will give you system diagnostic. They will give you if there's anything wrong with the channel, if there's anything wrong with the I/O card. And they will display this in a really clear manner, so the operator knows exactly what is happening. But also, and this is now something when we are talking about AI and all these new technologies, we're having a new proof of concept where we do the co-pilot for operation. So you have machine data and you have a documentation for the machine. And you combine it all together and help the operator to make sense of what is happening. Because nowadays machines are quite complex. And to get a little bit more light in the complexity, you can combine real data, you can combine manual data, club it together, and then the machine and the operator more or less is teaming up.
So kind of like contextualization of the data with additional information. Is this what you see as well?
We do, and you know, if we think about sort of the business case from a higher perspective, usually the two fundamental items are around quality and capacity. So thinking about how I can either increase my production rate or decrease the downtime of that asset, or increase the overall quality of the product itself, or the two dimensions that we often see with inside of manufacturing.
So earlier you said we are at the beginning of this transformation and we still have some ways to go, I think. So thinking 10, 15 years ahead, where do you see manufacturing, especially maybe you are being based in Singapore, like here in Southeast Asia?
Yeah. So in 10, 15 years?
In 10, 15 years.
Okay, I think here in Southeast Asia, and maybe it's in this region, we are still in the terms to create awareness, to really get the benefits of this digital transformation. What does a smart factory mean for really a manufacturing operator or for a complete line producer? And here I think we need to still do a couple of things. We need to prove what we are saying, walk the talk. So that's why in the department where I'm responsible for, we do a lot of proof of concepts on edge, on transparency, to really show the customers that we can do what we are telling them. And yeah, I think it might take a little bit longer, but we are getting there. It might take maybe another 10 years, but I am sure this is unstoppable. You cannot, in some applications maybe it needs more time, but also in some applications, especially machine builders, they understand what the need is to go the next step. Transparency, edge computing, artificial intelligence, data, and what the data means. Yesterday we learned on a shop floor, 85% of the data is there but not used. And to make it understandable and make sense out of it, that is the key. And this will take another couple of years.
So, and basically when I started with like Industry 4.0, I actually thought 2024 we would be further ahead than we are today. So do you think with kind of like the new hype around Gen AI, like this transformation will be faster now? So where, according to your opinion, will we be in 10 years in North America?
Yeah, so if we think about North America, we're well on the journey to Industry 4.0. It's interesting, Gen AI and AI in general is thinking about the usage of that data in different ways. So a lot of times people often think of Industry 4.0 in a lights out, no people involved. And I would venture to say that that's the wrong tact if we think about sort of the scale and the usage. It's about how to use those resources to manufacture the best that you can to that capability. So people are still involved, but they're enabled by different areas. So if we thought about, and I'll get around to answering the question, the 10-year projection, but if we thought where we were 10 years ago, it was about how to automate, how to use that data and extract that human completely out. We have created areas in North America where we've got data, but now we need somebody to take action on that data, right? We still have the human in the loop being able to make that decision. And what we did is, to Bernard's point, Bern's part is being able to take those elements and not only looking at them to have not just data, but insights, right? So it's not that it's just sitting there untapped. So in 10 years from time, we'll see the usage of the Gen AI to help items inside of Knowledge Worker. We'll also use those elements to make recommendation engines. So thinking about those holistically and add capacity without eroding in the talent base.
All right, so thank you very much for that projection and that insights, and I'm looking forward to talk to you maybe in Hanover then in 2025.
All right, thanks a lot. Thanks for having us.